When we're building machine learning pipelines for consumer-facing businesses, it typically looks like the following. Customer or user data will be collected from a touchpoint, for instance a web page, using a JavaScript-based tracking solution such as Google Tag Manager. This data is then sent back to the data lake or data warehouse, where the pre-processing, transformation, and modeling will take place. From there, the pre-processed feature data will be sent to a so-called online store like Redis, where it will serve as the foundation for the machine learning models in production. This is what we call our business-ready data. Redis is typically used as the online store, as it allows us to fetch the feature data with millisecond latency, avoiding costly delays on the consumer-facing front end. Now contrast this with how large language modeling pipelines and agents are currently being developed. Here we take a language model and we give it a tool, that is, the ability to call functions and retrieve any data that the language model might need to do its job. Then we might add retrieval capabilities that lets the agent fetch vector data, making this a RAG agent. We then tell the language model, this is your retriever, here are your tools, now go do your job. But this is handing off a lot of freedom and responsibility to a language model, and I would argue that this is too much freedom for a consumer-facing application. In this video, we're going to look at a different approach. We're going to set up a pipeline that mimics the approach we use for machine learning. That means we're going to let the language model consume vector data and the contextual data from the same database, in this case Redis. And the application-critical information about customers is going to be injected into prompt templates where it can be utilized for prompt engineering. That means we have one database. We'll have lightning speed contextualization, and we get to use the same infrastructure for both machine learning and language modeling. In the example I'm going to show you, I'll be using Shopify product data for the retriever. I'll be using LangChain and OpenAI for the language modeling, Google BigQuery as our backend, and I'll be using the open source feature framework Feast to build the pipeline from Google BigQuery to Redis. The video has 4 parts. First, I'm going to give you a brief overview of how Feast works with Redis and BigQuery. After that, I'm going to extract Shopify products from the API, transform the data into vector data, and load that data into Redis, enabling vector similarity search and making the products available for retrievers. Then I'm going to show you how to set up Feast with Redis as an online store and BigQuery as the offline backend. Finally, I'm going to give you 2 examples of personalized chains that could be used for marketing purposes. The first one I'm going to build is a personalized load summarize chain to be used for personalizing entire emails or email phrases. And the second one I'll show you is a personalized conversational chain to be used for developing personalized chatbots. The first thing I'm going to do is to set up a database on redis.com. It only takes a minute and you can get started for free. When you are signed up or logged in, you just choose a subscription and then you set up a database with a few clicks. And once we've set up the database, we'll need the host, port, and password in order to connect to Redis. And you get that by clicking connect. It's fairly straightforward to set up, but if you want a bit more detail, I've put a link to a Redis intro video below. Let's have a look at Feast. So head over to feast.dev and take a look. So Feast is a feature store or feature framework for production machine learning systems, and it's widely used and open source. So Feast will help you transform data from a backend like BigQuery and transfer that data to an online database that's used for feeding machine learning models in production, a database like Redis. And I'm going to show you how to set up Feast with BigQuery as a backend and Redis as the online store. To install Feast, you can simply run pip install Feast, but if you want to follow what I'm doing here, wait installing anything because we need a specific configuration of Feast that allows us to connect to BigQuery and to Redis. Let's head over to BigQuery and have a look at the dataset that we need for this. Here I am in the Google Cloud Console, the BigQuery SQL workspace with an overview of the different datasets. So here I have created a dataset that we're going to use to personalize the language models. The code for generating this dataset is also included in the Colab notebook. So we're going to be injecting incentive recommendations into LangChain prompt templates, as this allows the language model to tailor the copy used for hooking customers based on what we think the customer might respond to. In this dataset, we have email as the primary key. We have a first name, a last name, the recommended incentive, and 2 timestamps, one when the record was created and one when the feature was recorded. In order to create this dataset and to connect feeds to BigQuery, we need a key that will give us access. So I'm going to create a service account to do that. So go to the hamburger menu in the upper left corner, click APIs and Services, and then Credentials. And in here, we click Create Credentials and select Service Account. We'll just give it a name so we remember what it's for. Click Create and Continue. And we're just going to select BigQuery Admin as the role, and then Continue. And that's it. No need to fill out anything more. Just click Done. Now to get the key, we select the service account and we click Keys, Add Key, Create New Key, and then we select the JSON option. This gives us the JSON key needed to access BigQuery and to have feeds fetch the features from BigQuery and materialize the features into Redis. All right, so the cool thing about this is that we can do everything from a Colab notebook. So there's a bunch of libraries at the top here. We don't need them all in this video. You don't need the Klaviyo API unless you want to try to feed the output of the language model to Klaviyo. And you don't need Shopify either, because I'm going to provide you with the product data in a JSON file. So you can just load the product data into a pandas data frame and then feed it to Redis from there. And note that I'm not pip installing Feast yet. I'll do that further down in the notebook. So I have my environment file uploaded with the needed API keys, as you can see on the left. And I also have the JSON key that we just created on GCP that allows us to connect to BigQuery. So I'll start off by connecting to the database that we set up on redis.com using Redis Pi. And we need the host, port, and password for that. So I'll ping it to see if there's a connection. And as you can see, there are no keys in the database. So if you want to connect to Shopify, which is something you need if you want to put something like this into production, we have the code for getting the data, fetching the product data from Shopify, and transforming that data into a useful data frame. So I'm using the getData function to call the Shopify REST API, and here I use the attribute product to get the product data. Then I transform that data into a data frame. And from the data frame, I'll create lists with the product titles, and I'll add the rest of the product data as metadata. And here you can see the product data frame that we use as a basis for this. And you can fetch additional fields from Shopify if you want to. I'm just going to keep this light. So next up, I'm going to use the OpenAI embeddings, because we need that when we want to store this data as vector data in Redis. And then I'm going to use the Redis connector that's built into LangChain that allows us to write this data into Redis as vector data. So I included a dictionary with a vector schema here that we're going to be passing to the method, because that's what you need if you want to configure the Redis vector database from LangChain. I'm using the HNSW algorithm here. We could have used a flat one, and you can set that in the vector schema. So now we have the product data stored in Redis, and we can do vector similarity search over the products. So on the next cell, I've added code that you can use to delete these products again. Don't run this if you want to keep the products in there. And as you can see, we can now run a vector similarity search for Adidas shoes and get the top 5 results, and it works as intended. If you want to connect to this Redis database again from LangChain without pushing products, then you'll need the schema of the database. So write the schema using the Redis instance and the method write schema, and save it as redis schema.yaml. And remember to store this locally as well, so that you don't lose it when your online Colab notebook is reset. So this was one source of data in Redis, everything we need for building the retrievers. Now we need the personalization data. Here I have the code that I used to create the dataset that you saw in BigQuery. So these are the incentive recommendations I talked about. I'm not going to go into how these are created with machine learning. I'll save that for a later video. But here I'm just simulating a dataset that we can use for the generative AI part. I'm using the Faker library to create the names, and I'm using my own domain here. You don't really need that, but I'm using that because I want to be able to test the personalization pipelines down the line. And this will create a data frame with customer features that you can push to BigQuery using pandas GPQ and the JSON key we downloaded from GCP. And to do that, you'll need to set the credentials. You'll need a table ID, a project ID, and of course your JSON key. And this will simply create a new table in the personalization dataset in BigQuery. And if we head over to BigQuery, to the personalization dataset, you'll see that we now have a new table. And here it is with the exact same format as the other dataset in there. All right, so let's get to the most important part of the video, setting up Feast with BigQuery and Redis and using that with LangChain. So we're going to pip install Feast with GCP and Redis dependencies. And when you're done pip installing, we'll run feast init and the name of the repo we want to create. In this case, it's called LangChain Clavio, and we'll tell Feast that we are going to connect to GCP. And then you'll see a folder called LangChain Clavio to the left, and we can open that folder, and it's going to have a feature repo inside. And there are two files we're going to configure, example repo.py and featurestore.yaml. If we open the featurestore.yaml file, you can see that this is where we configure the connections to BigQuery and to Redis. And I'll show you in a bit what that looks like. Let's have a look at the example repo.py file. This is where the features are defined and the sources of the features are defined. And we're also going to configure that to be able to fetch the incentive data or the incentive features that we have in BigQuery. I have a featurestore.yaml file here on my local machine, and you can see how it's set up. I have the provider set to GCP. I have the offline store set to BigQuery. The dataset is called Personalization. Then we have the online store, which is Redis. And the connection string is simply the host with the port at the end, and then the password, which is in the same string but separated by a comma from the host and the port. And in the example repo.py file where we define the features, we have three things we need to set. We have the entity, which is the customer in this case, with the join key that's going to be email in our case. Then we have the feature source, which is BigQuery source in our case, the name of the feature source, the table, including the project ID and dataset name, and then the two timestamps we had in the table. And lastly, we need to define a feature view that also needs a name. We'll call it incentives. We'll use the entity we've defined, in our case, customer. And then we need to define the schema of the feature view. We'll get the incentive, we'll get the first name and the last name of the customer. And of course, we set the source equal to feature source, which in our case was BigQuery. So I'm going to copy the content of these two files into the files in the folder in the Colab notebook. All right, so now we're almost set up to transfer features from BigQuery to Redis.
So I'm just going to change the directory. So I'm in the feature repo folder, and then I'm going to move the key I downloaded from GCP, clavio.json, into the same folder. Then I'm going to set the Google application credentials environment variable equal to the path of the service account key, the JSON key. And after that, we can run feast apply, which is going to apply the configurations we just made in the YAML file and in the example repo.py file. And this is going to create a registry.db file with all the configurations. I'm going to show you that in a bit. But first, let's materialize the features and send the features from BigQuery to Redis. And we do that with feast materialized incremental, and then we pass the date. And this will send the changes that has happened in the offline feature store to the online feature store. So it's sending the deltas. All right, so the features have been written to Redis. Let's have a look at the registry.db file. You can see in the folder menu to the left that there's a new folder called data. And in here, you'll find the registry.db file. This can also be put on GCP. I'm not going to do that here, but you would do that in a production setting. So if we take the Redis Pi instance and we check the keys, you can see that we now have additional data written to the database. Besides the Shopify products, we also have the incentive data in the same database. And if you're taking this to production, you probably want to use two different databases, one for the features and one for the Victor data. So now we can extract these features from Redis and we can inject them into LangChain prompt templates. To do that, I'm going to import feature store from Feast, and then we're going to set the repo path. Remember, we're in the feature repo right now. And once we have the feature store and the repo path, we can use the method get online features. This will extract the features from Redis using the feature definitions. And here I've just hard-coded a customer name I know exists in the database. You want to change that to fetch any customer data given an ID. So if I run get features and extract the features for David Hill, you can see that I get the name and I get the recommended incentive, free shipping. So next up, we're going to inject this into LangChain prompt templates and create chains out of it. The first example I'm going to show you is the chain we can use for email personalization. So I'm going to import chat OpenAI. I'm going to import prompt template and string prompt template from LangChain because we need to modify or customize the standard prompt template. Then I'm going to import load summarize chain because that's the chain type we're going to use for the email personalization. Here we have the first template I'm going to use for email personalization, and I'm going to inject the customer features into the customer data tags. And I'm going to use the get feature function we just defined to inject those features into the prompt template. I do that by using the string prompt template that I imported from LangChain prompts to define a Feast prompt template, and this allows us to inject the features as keyword arguments into the base prompt templates. So if we try to call the feature prompt template with David Hill and Adidas shoes as an argument, you can see that we're injecting the features, and then we're referencing the Adidas shoes as the relevant product. So I'm going to put this in a load summarized chain now and feed GPT-4 with this template and the products that we retrieved with vector similarity search. So I'll feed the chain with the input documents and the email that is needed to fetch the features. And if I run this, you'll see GPT-4, which is the chat model we're using, formulate an email. And with this email, the language model is trying to hook the customer with free shipping. So it says, enjoy your favorite products delivered straight to your doorstep without any extra charges. And that's because we recommended free shipping as the incentive for David Hill. And of course, the language model also mentions the Adidas Superstars, which is one of the products that we retrieved with the vector similarity search. So instead of having GPT-4 write an entire email, we can also ask it to just write a few lines. I've done that here, and I've included the base prompt template for that as well in the notebook. Let's move on to the conversational chain, the chatbot. It's very similar to the load summarize chain. The base template for the conversational chain will also have the customer data tag where we can inject the features, the incentives in this case. Then we'll have a question posed by a human, the user, and then we'll have the relevant products, which is the context that we get from the retriever. Then we define a prompt template that will condense the question and the chat history into a standalone question. And that's basically what we need to set up the chatbot. I'll build it with conversational retrieval chain. I'll import async callback manager, streaming, callback handler to be able to stream the output back to the user. I'm also using a separate LLM to condense the question. We don't really need all that here. I'm just showing you how to set this up with all the bells and whistles and still personalize the chain. The important thing to note here is that we pass the feature prompt template in a dictionary as keyword arguments to the chain. So let's run this and see what we get. Let's first check that the feature prompt template looks like we expect it to look. And everything looks fine. So I'm going to call the chatbot. I know that we have some toddler sneakers in the product catalog. So I'm going to tell the chatbot that I'm looking for some cool kids sneakers. And I'll call the chatbot with the query, with the email of David Hill and the chat history. And here we go. The chatbot is giving us a response. And as you can see, it's referencing the Nike toddler shoes and some other kids items. And it's offering free shipping on all items. So the personalization with Feast and Redis also works for chatbots. And of course, you can build a lot more advanced examples if you enrich the feature store, but I will leave that for a future video.
That's it for now. If you enjoyed this video, like and subscribe. Thanks for watching.